Hello students, welcome to today's revision class. Today we will have a quick revision of electricity and magnetism. So you know there are two kinds of magnets, natural magnets and artificial magnets. The natural magnets are the magnets which are obtained from the nature, and the artificial magnets are the magnets which are made artificially. Natural magnets do not have enough magnetic power and they are irregular in shape. So that is why artificial magnets are made. There are many artificial magnets, bar magnets, horseshoe magnet, magnetic needle, magnetic compass. These are all examples of artificial magnets. First of all, we see some of the properties of magnet. The first property of magnet is attractive property. Attractive. What is meant by attractive property? So attractive property means the property of a magnet to attract some substances like iron. That is called attractive property. Magnet is able to attract certain substances towards it. That is called attractive property. The substances which are attracted by a magnet, that is called attractive property. And the substances which are not attracted by a magnet, that is called non-magnetic substance. The next property is directive property. Directive property. So directive property means, suppose that if you take a bar magnet, and suspend this bar magnet from a support by a silk thread in any direction, and when this bar magnet comes to rest, the north pole of the bar magnet points towards geographic north, and the south pole of the bar magnet points towards the geographic south. This property is called directive property. Now the next property is, suppose that if you bring the north pole of a magnet is brought near the north pole of another magnet. If you bring north pole of a magnet near the north pole of another magnet, they will move away from each other. That is called repulsion. The like poles, north pole and north pole, they are the like poles, and south pole are the like poles. Like poles repel each other. And suppose that the south pole of a magnet is brought near the north pole of another magnet, then you can see their attraction. So this is one of the properties of magnet. Like poles repel each other and unlike poles attract each other. So this is a third property. Like poles repel and unlike poles attract. Then if you break a magnet into small pieces, suppose that you take a bar magnet, this is north pole and this is south pole, suppose, and if you break this one into two pieces, then each piece will have both the polarities. This will be north and this end will become south, and this will be north and this will be south. And if you break it again and again into small pieces, all the pieces will have both the polarities. North pole and South pole will be there. Or we can conclude that a magnet with only one polarity cannot be made. Or we can say that no monopole exists. No monopole exists. So these are the properties of magnet. Now we see a test to find a magnet. Test to find a magnet. Suppose that you are given two similar bars. Two similar bars are given. One is a magnet and one is an iron bar. How will you find it? So you take both the bars. Suppose that the first one is you name it as A and the second one you name it as B. You suspend the first bar A and the first bar A, suspend it. So it remains as you have suspended. Suppose that you suspend it in the east-west direction. You suspend the bar A in the east-west direction. And it remains in the same direction, that is in the east-west direction. So it is only an iron bar. And you suspend the next bar B by using a silk thread in the east-west direction. But in the case of this bar, it turns and comes to rest in the geographic north-south direction. The bar which comes to rest in the geographic north-south direction is a bar magnet. And the bar which does not come in the geographic north-south direction is not a bar magnet. It is only an iron bar. Now the next topic is magnetic field. Magnetic field. So what is meant by magnetic field? So there is a space around a magnet where the effect of that magnet is felt. That is called its a magnetic field. The space around a magnet where the effect of that magnet is felt, that is called its a magnetic field. Now the next topic is electromagnet. What is an electromagnet? So electromagnet is a temporary magnet made by passing electric current. Electromagnet is a temporary magnet made by passing electric current. So how do we make an electromagnet? For making an electromagnet, you take an iron object and wind copper coil around it. Wind a copper coil around the iron object and connect the end of the copper wire to the terminals of a battery. As long as the electricity flows through the copper wire, that iron object will behave as a magnet. So this type of magnet is called electromagnet. Now let us see how do we make a bar electromagnet. So here PQ is a soft iron bar and a copper coil is wound around the soft iron bar. Then one end of the copper wire is connected to the positive terminal of the cell and the other end is connected to the negative terminal. In between, a key is also connected. As long as the electricity flows through the copper wire, this soft iron bar behaves as a magnet. This way, we make a bar electromagnet. For making a horseshoe electromagnet. We take a U-shaped iron bar, then winding copper coil around this. One end of the copper wire is connected to the positive terminal and the other end is connected with the negative terminal. So here also, as long as the electricity flows, this soft iron bar behaves as a magnet. Here we find the polarity by applying clock rule. Clock rule is this way. Look at the face of the coil. If the current appears in clockwise direction, that will be south pole, and where the current appears in anti-clockwise direction, that will be north pole. The strength of the electromagnet can be increased by increasing the current and also by increasing the number of turns. And electromagnets are used in many devices like electric bell, and it is also used for separating magnetic and non-magnetic substances, etc. So this is all about today's class. Thank you.